Hi guys, welcome back to another math lesson. We're finished with lines finally, and now we're moving on to something called parabolas. It's a pretty long section, so I'm probably going to split it up as we did before. In this section, we're going to in this part, we're going to cover what is a parabola, and we're going to get an idea of what they look like. So first of all, what is a parabola? So a parabola is the graph of a function that takes the following form. Y of x, so y takes in the value x and gives out a times x squared plus b times x plus c, where a, b, and c are fixed numbers and a does not equal 0, because if a equals 0, then it's just going to be a line. So a parabola is the graph of any function that takes this form, where a, b, and c are fixed numbers with a non-zero. B and c can be 0, that's still fine. Okay, so that's what a parabola is. Now we're going to get an idea of what they actually look like. So to do that, let's draw the simplest parabola we can think of, and for me that is y of x equals x squared. So we're going to graph y of x equals x squared. What does that look like? So this is our y-axis. This is our x-axis. I've drawn the x line so low because we're not going to need any negative values of y really. You'll see why soon. Okay, so let's get into it. When x is equal to 1, what is y? Well, y of x equals x squared. That means y of 1 equals 1 squared, which is equal to 1, because 1 times 1 is just 1. So when x is equal to 1, y is equal to 1. And that means that our graph, our parabola, goes through the point 1, 1. Also, when x is equal to 0, y is clearly equal to 0, because y of 0 equals 0 squared, which is 0 times 0, and nothing times nothing is still nothing. So 0 squared is 0, and when x is equal to 0, y is equal to 0. So our parabola goes through the point 0, 0. Okay, how about now x equals 2? Well, when x equals 2, y of 2 is equal to 2 squared, which is equal to 2 times 2, and 2 times 2 is 4. So when x is equal to 2, y is actually all the way up here. Y is actually equal to 4. So this thing is definitely not the same as a straight line. And finally, let's take x equals 3. This is probably the last one we're going to be able to fit in, because y of 3, when x is equal to 3, y is equal to 3 squared, which is equal to 9, because 3 times 3 is 9. So when x is equal to 3, y is actually equal to 9, and so our parabola goes through the point 3, 9. And when x is equal to 4, y is equal to 16, because 4 squared is 4 times 4, which is 16, and I can't even fit that in. It's way, way up there. Okay, so that's what our curve kind of looks like. Let's do a couple more values. Pick a different color. How about x is equal to 0.5? Well, when x equals 0.5, y of 0.5, let me draw up here, y of 0.5 is equal to 0.5 squared. 0.5 times 0.5, well, that's half of half, basically. So half of half is a quarter, which is 0.25. And so when x is equal to 0.5, y is actually equal to 0.25. I'm running out of room. I'm just going to get rid of that. You know where 0.25 is. So when x is equal to 0.5, y is equal to 0.25. And our parabola goes through that point there, the point 0.5, 0.25. Okay, how about 1.5? When x is equal to 1.5, y is equal to y of 1.5, and y of 1.5 is equal to 1.5 squared, which is 1.5 times 1.5. In other words, 1.5 times 1.5. Well, half of 1.5 is 0.75. So 1.5 of 1.5 is 1.5 plus 0.75, which is 2.25. So when x is equal to 1.5, y must be equal to 2.25, which the way I've drawn this should be about there, 2.25. And so our parabola goes through the point 1.5 and 2.25. And actually you'll find that as you plot more and more points, it basically gets closer and closer. That's pretty badly drawn. It basically gets closer and closer to this curved shape like this. See if I can draw this right. So it kind of makes a bit of a curved shape. I'll do another one later if that one doesn't get the point across. It's kind of hard to draw it. So it has a curve at the bottom, and it starts to increase more and more sharply as we go along, because when you square bigger and bigger numbers, it increases faster and faster. Okay, well, that's all well and good, but what about the negative side? Well, what's going on the other side of the y-axis? For example, what happens when x is equal to -1? What happens when x is equal to -1? Well, actually, it doesn't change very much, because y of -1 is equal to -1 squared, and -1 squared is the same as -1 times -1. Well, negative times negative makes a positive, and so that's just 1 again. -1 squared is just the same as 1 squared. So our parabola also goes through the point -1, 1. How about -2? Messing up the distances a little bit. How about when x is equal to -2? Well, when x is equal to -2, y of -2 is just -2 squared. So -2 times -2. Once again, -2 times -2 is the same as 2 times 2, because a positive times a positive is a positive. So -2 times -2 is the same as 2 times 2, which is 4. And so when x is equal to -2, y of x is equal to -2 squared, which is equal to 4. And similarly, when x is equal to -3, y is equal to 9. And when x equals -4, y of x is equal to 16, because -4 times -4 is the same as 4 times 4, which is 16. And again, you can fill in all the points in the middle if you want, but it's not going to change anything. It's just going to be a reflection about the y-axis, because when you put in negative x values to this function, it's the same as if they're positive. When you square it, the negatives cancel. So our curve looks like this on the negative side. And that's our very first parabola. That's the parabola y equals x squared. All right, we'll end this little section here, and we'll start up in another section. Take care for now. See you soon.